Hi everybody, I'm Sergio Alvarez, and today I'm going to talk to you about my PRO-Xperiment, which is called Enhanced Virtual Reality. Basically, during this project, I've been working with FEM models, FEM optimization, and virtual reality to solve one big problem, one showstopper for topology optimization, which are abuse loads and assembly loads, which is basically the loads our structures suffer during the assembly operation, or when a worker falls and falls on our optimized structure. So basically, topology optimization is a big step on structural analysis that allow us to reduce weights, reduce costs, make greener structure, just because we are reducing debris, we are reducing waste, we are reducing weights within, for example, in an aircraft means a reduction on CO2 print. So it is something very important that can lead us to another level on structure geometries and structure weights, but has some problems. So I've been thinking about how to solve it using virtual reality. Basically, I've been analyzing the state-of-the-art virtual reality devices. We have two different companies that are on the market, that are the cutting edge of the technology, that are Oculus Rift and HTC Vive. Basically, both are head-mounted displays with different controllers. For example, that are the ones for Oculus Rift. Like you said, it's very comfortable in your hands, but it has some problems. You can reproduce perfectly your hands movement. That would be very important in my project. So I prefer to use some kind of gloves that are under development to allow for a better hand movement recording, which would be very important. Talking about FEM softwares, basically all the big companies have an optimizer solver. In my case, I have centered on Inspire, which is a solver developed by Altair, in which you can use its own algorithm or algorithm developed by each user. It depends on how you prefer to work with optimization. My proposal is, once we have our model designed, our first optimization run, we can go into our headset, put our controllers on, and play with the structure. We can have it in your hands, we can stretch it, we can put it where it is supposed to be, in an interactive environment between our FEM solver and our virtual reality devices, in which all of our movement get recorded. We then can see how the forces were during the riveting, during the boring, when we put pressure on something in order to assemble it, and all of these forces get recorded, and we get through a reloop of the optimization, and now we have a part which is optimized to working loads, really optimized, but can also withstand abuse loads, assembly loads, which are really important, just because they don't need to be during the life of the component, but during maintenance, during assembly tasks, they are really determined. If we break a part, which sometimes is very expensive during assembly, it's a shame, and it's been really a showstopper for this technology. So it is very important that if this technology gets developed and companies get to accept it, I think it would be a big step on how we are using topology optimization nowadays. So to conclude, well, I think topology optimization is a really big step on structural analysis or structural design, but as we all know, it has some very important showstoppers that with this software, with this application, of virtual reality we can solve. We can put a worker and say, hey, this is our structure. We're gonna want to see how you use it, how you are going to put it on the table, how you are going to attach it to the main structure, how you are going to work with it, how it can fall from your hands, and we are going to record the loads is suffering, and then we are going to re-optimize the structure not only to work in loads but also to abuse loads and to assembly loads that can really enhance for a better use of topology optimization, which in the end would lead to weight savings, less CO2 emissions, less contaminants emission in general, just because we are producing less debris. And I think this application can be really developed, and it has to be the future of structures, topology optimization, and that kind of thing that allow us to a greener world, to produce lighter weights parts, and indefinitely to reduce debris, which is very high now on industrial production.